Okay, we are now about to start the real fun in trigonometry. We are going to be exploring the trig identities and how we can use those to help us to solve trigonometric equations. And in this video, we're going to start with the fundamental trig identities and how we can use those to simplify expressions or rewrite them. And there are several different types that we consider to be fundamental, and the first of which is the reciprocal identities. Those actually come from what we've already defined, but let's just review them here. I do suggest that you make note cards for all of these identities and spend some time each day committing them to memory. So we know that sine of theta is also equal to 1 over cosecant of theta. Cosine of theta is equal to 1 over secant of theta, and tangent of theta equals 1 over cotangent of theta. Likewise, cosecant of theta equals 1 over sine theta, secant theta equals 1 over cosine of theta, and cotangent theta equals 1 over tangent of theta. We also have what's called the ratio identities. All right? And those are the identities we get from taking the ratio of some of our trig functions. So the first one, tangent of theta, is equal to sine theta over cosine of theta. Some of these we should already know. We could also write tangent of theta is equal to secant theta over cosecant of theta, right? So this is 1 over cosine, and this is 1 over sine. And we could write cotangent of theta as cosine of theta over sine theta. And we could actually make lots of combinations, but these are the basics. All right, and probably the most important one that we'll discuss, or ones that we'll discuss in this video, are the Pythagorean identities. And for these, we're going to go back to our unit circle. All right, so I'm going to pull one up here. All right, here's an example of our unit circle, and let's recall what we know about a circle in general, and in particular, the unit circle. So if I were to pick any point, I'm going to put it right there, on the unit circle, xy, we know that it satisfies the equation x squared plus y squared equals 1. That's what it means to be on the unit circle. This is the equation of the circle centered at the origin with radius 1. So any point on that circle satisfies this equation. Now what we've learned is on the unit circle we can replace our x value and y values with our trig functions. So x is equal to cosine of theta, y is equal to sine of theta, when theta, so if I were to draw the angle that corresponds to that point, then we can replace our x with cosine theta and our y with sine of theta. This means, recall this is really my x and this is really my y. Since x squared plus y squared equals 1, we can now write it as cosine squared of theta plus sine squared of theta equals 1. And this probably is the most important of them all. Commit, commit, commit that one to memory. Okay, we can actually see this particular one in two other forms. I could solve for cosine squared here, and I see that cosine squared is also equal to 1 minus sine squared of theta. Or I could have solved for sine squared, and I see that's equal to 1 minus cosine squared of theta. These are really three of the same ways to write this particular one. So cosine squared theta plus sine squared theta equals 1. Okay, from this one we can actually get two more of the Pythagorean identities. So let me remind us what we had here. So let's put this back up here. So we know cosine squared theta plus sine squared theta equals 1. Now let's come over here and do some work. If I were to take this identity right here and divide through by cosine squared, let's see what we get. Okay? So if I divide every term by cosine squared, let's see what happens. Equals 1 over cosine squared theta. Well, cosine squared over cosine squared becomes 1. plus sine squared over cosine squared is the tangent squared of theta, and 1 over cosine squared is equal to secant squared theta. So this one is number 2. If we consider this one number 1, this one's number 2. That's the second of our Pythagorean identities. All right, let's look at the third. We can get the third one from our first one, but this time let's divide through by sine squared theta. So we start with our first, cosine squared plus sine squared equals 1, and this time we'll divide through by sine squared of theta. Yep. So cosine squared over sine squared, that becomes cotangent squared of theta. Sine squared over sine squared is 1, and 1 over sine squared is cosecant squared of theta. So this one is number 3. So let's write them all together in a line here. 1 plus tangent squared theta equals secant squared theta, and cotangent squared theta plus 1 equals cosecant squared theta. You need to learn these. Commit. Does commit have 2 M's? I think it does. Commit to memory. Okay, let's see how we might be able to use this with one quick example. All right. If I wanted to show the following, I want to show that the sine squared of x times the cotangent squared of x plus sine squared of x equals 1. Now, you might ask yourselves, well, why would I ever want to show that? Yeah, that looks a little sketchy, so let's rewrite that. Well, in calculus, you are going to want to solve equations that involve trig functions. You're going to want to differentiate trig equations with trig functions in them and integrate them. And you need to be able to simplify expressions or rewrite them in a way that you can do things with. So we're going to have practice doing that. So to show something, you're going to work with one side of the equation and show that it equals the other. So I'm going to start with this one, and I'm going to do it by factoring out first. There's lots of ways to show something. This is what I see to do. I'm going to factor out a sine squared. So if I factor it out of this term, I leave behind a cotangent squared. If I factor it out of that term, I leave behind a 1. Oops, we're showing that, so we don't know yet that that's what that equals. I realized that cotangent squared plus 1 was one of my Pythagorean identities, and that's equal to cosecant squared. So now I have sine squared x times cosecant squared of x. Is this indeed equal to 1? Well, I can rewrite cosecant squared as 1 over sine squared. And sine squared times 1 over sine squared is 1. And that's just one example, and we'll actually explore many, many more.